right quick. So yeah, you can just write that number out, and you can go from there. But the setup is the exact same as the first problem before it and the one we did after. It's the exact same setup. Let's go to number 4 right quick. It just says determine the mass. Notice what it's asking for, mass of each of the following. We have moles. How do we interconvert? What's the relationship between mass and moles?
Is it grams? Right, over mole.
Yes, molar mass is grams. So if we have moles and we're looking for mass, we can manipulate the molar mass relationship, right? So moles, so grams is going to be what? Molar mass times moles. And that's for all these problems. They all give you moles and they all ask you to find the mass. So you take that same relationship and just keep using it. So if I were to take the first one, 0.0, thin my pen out just a tad, 0.0146 moles of KOH. Why is it giving me KOH? Why do I need that?
To find the molar mass.
The molar mass. Without the molar mass, I can't find the moles because I don't have anything to put in that equation. So if I know the molar mass of KOH, which is roughly 56 grams per mole, so that's potassium, which is 39, and then the oxygen is 16 and the hydrogen is 17. I'm rounding all those numbers to whole numbers. It'll just be 56. So this will be times, not times, 56 grams per mole. Now your numbers may come out a little bit different because if you use the exact numbers off the periodic table for your masses to get your molar mass, the numbers will be off by decimal, but that's fine. The whole number in front of the decimal is going to be identical no matter what, but the decimals might be a little bit different. So it'd be 0.0146 times 56 grams per mole, right? And that should give me, what is that in grams? Let me see. 1.5% of that. Let me get my calculator. Right? Or somebody can also be calculating that 0.146 times 56. Anybody got that? 0.8176 grams.
Yeah, that's what I got.
And see here, when you do grams, moles times molar mass, moles cancel. Right, so because moles are in the denominator of molar mass, so that's going to cancel. All right, let's do B, 10.2 moles. So we know how many moles we have. I don't like this red. And we're going to multiply that by the molecular weight of ethane, which is 24 and 6. 30 grams per mole. Is that right? 2 times 12 for carbon and 6 times 1 for hydrogen. So about 30 grams per mole. So moles are going to cancel. 300 and some change. 306. Right? Somebody do the next one for me. And if you want to write this out, this is another one, Maya, kind of like the other one up top. You can just write it out.
Question: where are you getting these numbers from?
What numbers? The 30 and the 56?
Mm-hmm.
Right here. 2, so it's 2 carbons and 6 hydrogens. So that's 2 times 12 for carbon. And that's 6 times 1 for hydrogen. These are the atomic masses, remember? That's how you get the molar mass, by adding up all the atomic masses.
Mm-hmm. Thank you.
Mhm. So this is this. We got to find the formula weight or formula mass for sodium sulfate. So that's going to be what? 2 times sodium, and then 4 times oxygen, and then 1 times sulfur. So this is going to be 64. I think sulfur is 32, and then sodium, I'm drawing a blank. What is sodium? Is it 44?
32. 32.
For sodium?
Sorry. So no, it's 23.
23. So 2 times that. 40, so it's 46, 64, and 32. So the total molar mass for sodium sulfate would be, what is that? 64. So 140. Yeah. Am I right on that? I don't think I'm right on that. It's not 140. 64 and 32 is 96. And 4. Yeah. 142. All right. So then you just take this number and multiply it. Right. We found the molar mass. So this is 142 grams per mole. What's that number?
Times the 0. Oh no, you wrote it out. Never mind.
Yeah.
I got 0.2272.
Okay. All right. So, and that's in grams, right? Because we're looking for mass.
Yes.
Right. So the key to these questions like this, if it gives you the mass and the molecular formula, it's just figuring out what the molar mass is. Once you do that, then the rest is cake. It's just multiplying the moles and the molar mass together to get grams. All right. So you can work on D and E. All right. Let's go to the next problem. Any questions about these? So if you have, if you're given mass and moles, you just need to find molar mass. All right, let me put that over here in a right. If you got those two values, the mass and the molar mass, then what you're looking for is grams, right? And it asked us here to give you the, I said mass and molar, moles and molar mass. You'll find grams if you're given the mass. All right, let's go to the next question. 55 kilogram woman has 7.5 times 10 to the minus 3 moles of hemoglobin, molar mass 64,456 grams per mole. Wrong pen. In her blood, how many hemoglobin molecules is this? What do we need to find out first? Because we can't go. Oh, yes, we can. What do we need to find out first? If we want to go from moles to molecules, do we have a direct way to do that? Her weight or her mass is irrelevant. It doesn't matter. So we ain't even concerning ourselves with that number. All we care about is this number right here. Right, 7.5 times 10 to the minus 3 moles of hemoglobin. There's a direct way to go from moles to molecules, isn't it?
Is it with the Avogadro's number?
Yes, indeed. Take the number of moles, 7. So fine, let me put this here. Fine. Come on, Russell. Molecules. And we're going to use Avogadro's number, N, uppercase N with a subscripted uppercase A, right? So it's going to be 7.5 times 10 to the minus 3 moles times 6.022 times 10 to the 23rd. And then the top, remember, we can put whatever we want. So we want molecules per mole. Is that right? So moles are going to cancel. All right. Anybody calculated that yet? All right, I have 4.67 times 10 to the 21st molecules. Anybody else got that?
I got the 10 to the 21st part, but I got 4.5.
Oh, hold up. Oh, my bad. Well, let's keep what we have, because I think in my calculations, I calculated, I used the wrong number. I used 7.75. You said you got 4.5.
Yeah, I got 4.5165.
All right, so we're gonna go with 4.5.
2. Oh.
We'll put 5 too. That's fine. Times 10 to the 21st molecules. Yeah, my calculation on what I did when I was working through these, I used 7.75. That's my bad. All right, so that we know the molecules. Now it says what quantity is this in grams? What do we need? They gave us, this is a rare case where they gave us everything we need. And we don't have to derive anything.
You multiply the molar mass number by the number we got?
Well, we don't need the molecule. We can't do it times molecules. We can do it times moles, though. So that's going to be 7.5 times 10 to the third minus 3 moles times the molar mass, which they gave us, which is 64,456 grams per mole. So moles are going to cancel. We're left with grams. Hemoglobin is heavy. Wow. I didn't know that was the molecular weight for it. But if I'm not mistaken, it contains like iron. So it contains some heavy metals. All right. Anybody got that yet? 7.5 times 10 to the minus 3.
Yep, I got 483.42.
Good. Okay. 483.42. And this is grams. That's almost that's a little bit over, let me think, a pound. That's a little bit over a pound. Wow. That's quite a bit, because a pound is 454 grams. So that's quite a bit. All right. Let's go to number 6. Let's answer that real quick. What information is needed to determine the molecular formula of a compound from the empirical formula? What do we need to find? We just did this too. Anybody remember that? how do you find you need the what's called it? You need to find formula units, don't you? Is that right? So it's the molecular is that right? The molecular weight of the compound divided by the molecular weight of the empirical formula. Isn't that right? That'll give us N formula units. So you need those two molecular weights. And then go ahead. And you'll take that N number and multiply it through the empirical formula to give you the molecular formula. Is that right?
Yes.
Mm-hmm. So we need in order to find the molecular formula from the empirical formula, we need the molecular weight of the compound. We need the molecular weight of the empirical formula. And once we do that, we can find the formula units and then multiply that by the empirical formula, and it'll give us the molecular formula. Now that it sounds like a lot, but we know how to do both. We know how to calculate the empirical formula. We know how to determine the molecular weight, and we know how to determine the molecular weight of any given compound. All right. Let's do 7. This is not, it looks like a lot, but it's not. So I said, determine the percent ammonia in this compound to 3 sig figs. So what do we need in order to determine the percent? We just did this. This is just like the problems that we did the other day. What do we need to determine the percent? What is that called when we talk about percent ammonia?
Percent composition.
Percent composition. Excellent. This is a percent composition problem. So we need to know the molecular weight of cobalt or trichloro ammonia cobalt or cobalt trichloroammonia. We need to find the molecular weight of that. So let's do that. So cobalt is 58.93. We're going to do the NH3. We're going to keep that together because that's what we're looking for. So the total here is going to be 17. And then chlorine is 35. All right, so N is 14, H is 1. So the total for the ammonia segment is 17 grams per mole. So we're going to keep that together because that's what they asked us for. All right, so now how many cobalts do we have? Just one, right? And then we got 6 of these and 3 of these. So this is going to be 105. This is going to be 17 times 6, 102. And this is all in grams per mole. And then 58.93 grams per mole. Right, so let's total those up because that's what we need. Once we get that, we can go back and do the percentages. 58.93 plus 2 plus 105. Anybody got it?
I got 265.93.
Come on with the come on. 265.93 grams per mole. Good, excellent. So now if we want the percentage of ammonia, what do we need to do? We need to go in and take this number out and divide it by the total, right? So the percent ammonia is going to be 102 divided by 265.93 grams per mole. And this is also in grams per mole. So those units are going to cancel out. And this will be times 100. Somebody got it? Anybody got it?
38.35.
Okay, so 38.35%. All right, let me ask this question. What would the cobalt and the chlorine be relative to ammonia, percentage-wise? What would the total of cobalt and chlorine be, percentage-wise? Remember, anytime you do percent composition, the total has to be 100%. So what would the total percentage of cobalt and chlorine be if I ask you something like that on an exam?
For this, would it be 61.65?
61.65. That's right. Right. And of course, we could calculate it because we know the masses, but the molecular weights. But I'm just asking in the sense that sometimes you'll get questions like that, where they'll give you a partial percentage, and then you might have to figure out the other two based on what's left of that. Right. So if we said that cobalt and chlorine the total was 61.65, then we could find out what percentage of that is cobalt and what is. So I'm just asking because sometimes you'll see questions like that where they'll give you a part of it, but then you have to figure out the rest. All right. So now let's go to number 8. Determine the molarity. What is molarity? What's the symbol for it, and what's the units?
The big M and then moles of solute divided by liters of solution.
Excellent. Moles of solute, if I can spell today, over liters. Come on, Russell, tighten up. Ordered a new stylus. Hopefully it'll be here today. So my chicken scratch can turn into a little bit, some more legible. Moles of solute over liters of solution. All right. So in the first question, number 8, it gives us the moles of solute. It tells us that we got 0.44 moles of cobalt 2 chloride. And it also tells us that we have 0.654 liters of solution, right? And so we're going to just take those two numbers and put them over top, over top of each other. So it's going to be 0.444 moles divided by what? 0.654 liters. And then that's going to give us the molarity. Anybody got it? 4 divided by...
I got 0.679.
Be absolutely correct. 679. And we're going to put M. And if I ask you what the M meant in this number, what would you say?
Moles per liter.
Yeah, moles per liter, or we can say 0.679 molar. So it's 0.679 molar solution. All right. All right, let's do the next one. 98. See, here we go. So now what is it giving us? Grams of phosphoric acid in 1 liter of solution. All right. So it's giving us grams. We need moles. How do we convert? Right? How do we convert grams into moles? That's one of the biggest things that we learned in this section. And without it, all these questions are going to be like Greek or Chinese.
Don't we need to divide the grams by the molar mass?
Yes. So we need to figure out what the molar mass of phosphoric acid is. We can, as a matter of fact, we know that we'll add the atoms together. You got 3 hydrogens, 4 oxygens, and 1 phosphorus. So that's going to be 3 phosphorus, I think is, what is phosphorus? Is it 30? 30,
It's 30.9.
30.9, so 31. And then oxygen is going to be 64, because that's 4 times 16. Right, so what is that? 98. So this is 98 grams per mole. Is that right? Roughly.
Yes.
So we're going to just take that. That's why it's important to understand how to calculate molar mass. That's why that was the very first thing we did. And all this is just repetition. The more you do it, the better you get at it. So it's going to be 98. It's going to be 98 grams divided by 98 grams per mole. Nice little trick. Right, and then we'll be left with moles. So grams are going to cancel. And we end up with what? 1 mole, right? So then now we can take that and put it in the equation. M equals, obviously, going to be 1 mole over 1 liter. So it's a 1 molar solution. All right. So now let's kind of speed this up with the next one. Somebody Google the molecular weight for calcium hydroxide. Because we got another problem here where we got grams, we got to convert into moles. Anytime you have that for a molarity problem, you have to convert it to moles using the molar mass. And we have another problem too, because this is in milliliters. So that's got to be converted to liters. And this has to be converted to moles.
$74.093.
So 74.09 grams per mole. That's our molar mass for calcium hydroxide. All right, so now we can just go ahead and convert this. This is going to be 0.2074 grams divided by 74.09 grams per mole. So the grams are going to cancel. How many moles is that?
Zero 0.0028.
0.0028 moles. All right, so now we need to convert 40 mils into liters. So that's going to be 40 milliliters times 1 liter over 1,000 milliliters. So that's going to cancel. So that's going to leave me with 0.040 liters. So now put those numbers together in the molarity relationship and find the molarity. All right, so we'll do it. I'm going to change the color. It's going to be 0.0028 moles divided by 0.040 liters. And what is that number? Anybody?
0.07 M.
Yeah, okay. All right. Shrink some of this down. I'll clean it up before I post it. All right. So 0.07 M. So we took this number that we calculated here, and we took this number that we calculated here. and got moles per liter. All right. So you can do D, E, and F. D and F are going to require conversion to grams. And then to moles, right? Same thing here. And then also, well, let's go ahead and do D because D is kind of tricky. Because with the molecular formula right here, you see how this is what's called a hydrate. So we have to include that water. So water, we're not even going to worry about calculating all this. This is 180. Because water is 18 grams per mole, and you got 10 of them. So we're going to include that in the calculation for, with sodium sulfate. Can somebody Google the molecular weight of sodium sulfate? So anytime you see a formula like that with the water attached, like 10, 8, this would be called a decahydrate, sodium sulfate decahydrate, because it's 10 waters. If it was 5, it would be pentahydrate. 7 would be heptahydrate, so on and so forth. So this is sodium sulfate decahydrate.
I got 142.04.
So this is the total is what would it be? 322.04. I don't know why my dog is barking, but I do know why. Slap him. You said 142.04, right?
My dogs can hear him and they like, who's that?
Yeah.
I know why he's agitated though. My daughter she's supposed to be going to their school's basketball game. They're playing for the state championship today. And one of her little buddies just pulled up. Hold up. Sorry. I'm not even going to delete that when I upload it to YouTube. Life happens. So you got sodium sulfate decahydrate because there are 10 waters attached to that sodium sulfate molecule. So we calculate the molar mass based on all of that. So the 142.04 for sodium sulfate, 180 for water, for the 10 waters, and then we just add those two together. And it was 322.04 grams per mole. Now we can use that to convert kilograms or grams into moles from the 10.5 kilograms. And they gave us the volume in liters. So we don't have to worry about that conversion. So I think y'all can handle it from there. So that's that. And then this has to be converted into grams and then to moles using that molar mass, and you're good. So the moles would be, what would that be? 10 kilograms times 1,000 grams. That would be divided by so you just take the number of grams and then divide by the molar mass, get the moles, set it up. M equals moles over liters. All right, and you should be able to handle, it's the same in F and E. You should be able to handle those two. All right, let's do one more. And then we're gonna actually stop. I'm gonna let y'all go and enjoy your spring break. Let's do number 9. It says, consider this question. What is the mass of solute and 0.5 liters of 0.3 molar glucose used for intravenous injection? All right. So this question gives us a molarity, which we know is moles per liter, moles of solute per liters of solution. And it gives us volume, my bad. And it gives us the molarity here. So we can solve for it. So M, if M is moles of solute and divided by liters of solution, and it gives me the amount, right? It gives me the volume of solution. We can solve that. So we can say M, and this is for any concentration. If you got the molarity and the volume, you can find the moles. So it'll be M times V equals moles, right? But it didn't ask for moles, it asked for mass. But then we can find that too. So first, let's find the number of moles, right? So the M is what? 0.3 moles per liter times 0.5 liters. So liters cancel, we get left with moles. What do we have there?
I got 0.15.
0.15 moles, good. All right, if we have moles and we want grams, what do we need? We're gonna beat this dead horse to death. If we got moles and we're trying to find grams, what do we need?
The molar mass.
Molar mass. And it told us that we're using glucose. So what do we need to take those numbers, those subscripts and those atoms, and we need to turn them into what? A molar mass, right? We know a way we can do that quickly. You can Google it, but we can also say that this is 72 because carbon's atomic mass is 12. This is 12, and then this is 96. Is that right? Because it's 6 times 16, 6 times 12, and then 12 times 1. Everybody agree with that?
Yes.
We should be at the point now where we can spit these atomic masses and molar masses out, no question. All right. So now, what's the molar mass? Let me see, 84 and 96. What would that be? 160? Or 170?
I got 180.
180? 84. Yeah, 180, 180, 180. You're right. So this is 180 grams per mole. Right? Once we get this number, what do? Take the moles and multiply it because we know the relationship moles times molar mass equals grams. Right? So we found the moles first. We found the molar mass. And then 3, we're going to take that. I'm going to move this over so you don't confuse it with that for initial calculation. All right, so we're going to find the grams from moles that we found and the molar mass that we calculated, which is going to be 0.15 moles times 180 grams per mole. The moles are going to cancel. Is that right? It should be something like
27 grams.
Yeah, 20 something. Yep. These are 27 grams. All right. Any questions about that? So they gave this. Let's recap this question, then we're going to stop. They gave us the volume of the solution that's used. They gave us the molarity, and they asked for the mass. But we can't go directly from molarity or volume to mass. We can do it with the volume if we had the density, but we don't. So we had to first use what we had to get what we needed. So we have the volume and the molarity. We use that to get moles. And then we had the molecular formula, which we could use to find the molar mass. So we use the moles and the molar mass to get grams. All right. So when you see a question like this, again, you have to always ask, what do I have? And then ask, what do I need? Right? So I have volume and molarity and molar mass. I need mass. So I need to find a relationship between the volume and the molarity and the molar mass that can give me mass. And that is that the molarity and the volume can give me moles, and then I can take moles and turn that into mass using the molar mass. All right, we're gonna stop here. And yeah, we'll stop. And then we'll come back after spring break, hopefully